Okay, going to be working the homework here for section 3.5. Make this a little smaller. Okay, so 3.5 graphing techniques. This first one we're supposed to match. So we're supposed to drag these and drop them in. So let's take a look at this function here. Might need to make it a little bigger here. This is a parabola x squared. We can tell by the shape. It looks like a U. Looks like it's been moved up 1, 2, 3 units, and it's been reflected over the, like it was reflected over the x-axis and then moved up 3. So we should have, let's see, x squared. Here we go. Here's a negative in front of the x squared that reflects it over the x-axis. This moves it up 3 units. There we go. Uh-oh. Why didn't that work? There we go. Okay. This one is parabola x squared, but it's been moved to the 1, 2, 3 units to the right. So anytime we go left and right, it's opposite of what you think. So instead of adding 3, we're going to be subtracting 3, but inside the function. So that would be right here. We're going to be subtracting 3 inside the squared function. So that goes there. Okay, this one here is a V, so it's an absolute value function. It looks like it's been flipped over the x-axis and moved to the 1, 2, 3 to the left. So we should have a negative in front of the absolute value function, and then it should be a +3 inside. Negative out front and a +3 inside. There we go. Okay, and then this one is just the absolute value function has been moved up 1, 2, 3 units. So should just be the absolute value function and then add 3. There we go. Oh, that's it. Okay. What am I missing? This one? Let me look at that again. Absolute value. Oh, it's sorry, it's been reflected over. Sorry, forgot to reflect it. Yeah, no, hold on. Up 3. Hold up a second. Absolute value of 3 flipped over. I don't see what the problem is here. That is the absolute value function, 1, 2, 3 units up. It's been reflected over the x-axis, so reflection then up 3. Yeah, that should be right. Let's, oh, why didn't it? Oh man, I think that was a mistake in this online system. I can't go back, can I? Okay, let's do this one. So this one here, parabola, 1, 2, 3, 4 units up. It's been reflected over, so a negative in front and moved up 4. Oops. There we go. This one, it's moved to the right, 1, 2, 3, 4 to the right. So I should be subtracting 4 inside the function. It's a parabola also. Subtract 4 inside the function. Okay, this is absolute value. It's been flipped over the x-axis, so negative in front, and then 1, 2, 3, 4, 5 to the left. So I'll be adding 5 with a negative in front. Negative in front and adding 5 inside. There we go. Okay, let's try this. Okay, 1, 2, 3, 4, 5 up. It's been reflected over the x-axis. Absolute value function. This is what I got wrong last time. So here, this reflects over the x-axis, and then this moves the whole thing up 5. This should be it. Yeah, see, I don't know. I think that last problem was messed up. All right, question 2. All right, so for this one, we have a parabola. It's been moved up 1, 2, 3 and reflected over the x-axis. So the reflection over the x-axis is here, then up 3. Okay, this one just been moved to the right 3, so we should, and it's a parabola, so we should have a -3 inside the function here. Missed it. It's kind of a pain in the butt. Okay, this one is absolute value. It's been moved 1, 2, 3 to the left and flipped over. So I should have a negative in front of it and 3 to the left. So -3, where is it? Flipped over, 3 to the left. What is it? Hold on. Absolute value function, 1, 2, 3 to the left. So we should be adding 3 and then negative. Oh, there it is. I didn't see it. There, and then this one just moved up 3. Absolute value flipped over. So I'm gonna flip it first and then move it up 3. That's it right there. See if it gets that one. Okay. All right, this one, parabola, this just looks like x squared, but notice that at 0, you get 0. At 1, you get 1, 2, 3. You get 3 coming out. So we've stretched it vertically. Normally when you plug in 1, 1 squared is 1. So we've pulled this point up. So this should be like 3x squared. Or, oh wait, was that 5? Hold on, let me, oh, wrong one. We go out 1, we go 1, 2, 3, 4. It looks like 4. I can't get that any bigger. 1, 2, 3, 4. It looks like 4. There we go, that one. Okay, this one, we just take a parabola. Look, if we start out, we go to the right one, up 1. So this is a normal parabola, but we move the whole thing 1, 2, 3, 4 units up. So it's a regular parabola, 4 units up. Okay. This one, absolute value function. And let's see, when we plug in 1, we get 1, 2, 3, 4, 5. It looks like -5. So it's an absolute value function that's been flipped over the x-axis and stretched vertically. So -5 out in front of an absolute value, this one. And then this one is, looks like a normal absolute value function because you go the right one, up 1, right one, up 1. And it's been moved up 1, 2, 3, 4, 5. So it should just be the absolute value function plus 5, this right here. Okay, this one, squared function. Move to the right 1, you go up 1, 2, 3, 4, 5. Looks like 5 units up. So it should just be 5x squared. This one, go to the right 1, up 1, right 2, up 4. So it's a parabola, regular parabola moved up 1, 2, 3, 4, 5 units. So regular parabola moved up 5 units. There it is. That's it. There we go. This is an absolute value function. You go to the right one, down 1, 2, 3, 4. It looks like 4 units down. It's been flipped over, so it should be -4 in front of the absolute value. There we go. And this one, absolute value function, right one, up 1, right one, up 1. It's been moved up 1, 2, 3, 4. So it should just be the absolute value of x plus 4. All right, this is pretty monotonous. Okay, for this one, this is a x squared. It's been flipped over, so -x squared, and then 1, 2, 3, 4, 5, 6 to the left. So we should be adding 6. So we should be adding 6 inside and then negative to flip it over. This one is a parabola. It's been flipped over, so negative, but we go 1, 2, 3, 4, 5. It looks like it's been stretched out by 5, or maybe 6. It's this one, but with a negative in front. Maybe it was 6. I did count it kind of quick there. This one, absolute value function. You go the right one, up 1, right one, up 1. But the whole thing's been moved to the right 1, 2, 3, 4, 5, 6. So it's the absolute value function, and then we have to subtract 6 on the inside to make it move. There we go. And then this one, regular absolute value function, but when you go over 1, you go up 1, 2, 3, 4, 5, 6. So we've stretched it out by 6. So it's absolute value. So here it is, 6 absolute value of X. All right. Okay, this one, move to left 1. This is a regular old parabola. Move 1, 2, 3, 4, 5, 6 to the left. So regular parabola, we're going to add 6 on the inside. It's been moved, it was to the left, yeah. So add 6 on the inside. And it was down. What the heck is it? Add 6, there we go. Okay, and then this one is regular parabola, but it's stretched. 1, 2, 3, 4, 5, so 6, but we flipped it over, so negative 6x squared. Another absolute value, 1, 2, 3 to the right, which means we're going to subtract 3, and it's the regular old subtract 3 on that. So absolute value, subtract 3 on the inside. There we go. Subtract 3 on the inside. Okay, this one, absolute value function, but it's been stretched. 1, 2, 3. It's stretched by 3, so 3 absolute value of X. There we go. Finally, something. Find the function that is finally graphed after the following transformations are applied. Okay, so the first thing we're going to do is we are going to shift it down 4 units. So we take the square root of X, we're going to subtract 4, that'll move it down. Reflect it about the X-axis, which means we wanted to reflect it, so put a negative in front of the function. And then we want to reflect it about the Y-axis, which means we want to put a negative in front of the X, like that. So let's try that. Y equals negative square root of negative X. And then we want on the outside of that minus 4. Okay. What the heck's going on? We want to. Okay, so they want this in this particular order. All right, we can handle that. All right. Whoa. Okay, so here's what they want. They want us to do this in order. You start out with square root function, looks like this. We shift it down 4 units. So 1, 2, 3, 4. Now it looks like this. So that's square root of X minus 4. Then they want that reflected over the X-axis, which means we have to take the entire thing, put a negative like that. Okay, that will make everything flip over the X. So now it'll look like this. And then they want to reflect that over the Y-axis. So that's when we put a negative in front of this X. So it should be negative, and in parentheses, square root of negative X and then minus 4. We can distribute the negative through and get negative root negative X plus 4. Let's try that. Go back in here. Change that to a plus 4. Okay. The order they wanted this done in a particular order. So I was initially saying that they didn't care about the order, but they do. Okay, so this one, we want to take this square root of X, which again looks like this. First thing we want to do is reflect it about the X-axis. So make it come down here. So we put negative root X. And then we want to shift it up 9 units. So we're going to go up 9 and then move it to the right 7 units. That means we need to go inside and we need to move it right. To the 7 units, we have to subtract 7, which is opposite of what we think, and that should do it. So let's try this. We're going to have negative square root of X minus 7, done with the square root, and then plus 9. Okay, next one. If negative 4, 2 is a point on the graph of y equals f of x, which of the following must be on the graph of negative f of x? So If we change this to negative f of x, all that does visually, what they're saying is this point, negative 4, 2, is on the graph of f. Negative fx will be a reflection over the x-axis. That would be this point, which would be negative 4, negative 2. So it should be negative 4, negative 2. All right. If the point negative 7, 3 is a point on the graph of f of x, then which must be on the graph of 2 times f of x? So that means we double it. So remember, this was 3. So we double that, that would come up here, and now it'd be 6. So the points negative 7, 6 should be on there. Suppose that the x-intercepts of a graph are given here. So suppose the x-intercepts of a graph are negative 5 and positive 7. So these points are on our graph. Okay, what are the intercepts of the graph y equals f of x plus 8? So what does this do? This moves it to the left 8. So that means it's going to move this to the left 8, which would drop it off at negative 13. And this to left 8, which would drop it off at negative 1. So these are the 2 new x-intercepts of the new graph. So we want commas between these, negative 13, comma, negative 1. Okay, what are the x-intercepts of the graph of, I erased it, of x minus 3? So again, we start off, we had the original x-intercepts of negative 5, positive 7. This time we're going to be moving to the right 3. So moving this to the right 3, we're at negative 2. This to the right 3, we're at 10. So we will have negative 2 and 10. All right, and then what are the x-intercepts of the graph of 5 times f of x? So this is important. We know, let me erase all this. We know that the original function has x-intercepts at negative 5 and 7. That means if we plug negative 5 into the function, we get 0. If we plug 7 into the function, we get 0. So if I then ask, what is 5 times f of, let's say at one of these points, this is going to be 5 times 0, which is still 0. And if I do 5 times f of the other x-intercept, that's still 5 times 0, which is still 0. So by scaling the function by 5, that does not change the x-intercepts. They still remain the same. They remain the negative 5 and the 7. Okay, what are the x-intercepts of this? So clear this out. So again, if we have negative 5 and 7 are the x-intercepts of the original function, then f of negative x, that reflects it over the y-axis. So this comes over here to negative 7, and then this reflects over here and becomes 5. So our x-intercept should now be at negative 7 and positive 5. All right, clear this out. All right, so suppose that a function y equals f of x is increasing on some interval. So let's say that between 6 and 9, my graph is going up over here. Okay, that's what f is doing. Okay, the graph of y equals f of x plus 6 is increasing over one interval. So if we were to take this whole function, add 6 on the inside, that moves it to the left 6. That would move this to, too far. That would move this to 0. It would move this to 3. It would move it to the 6. 6 to the left. So now the function would move over and it would be like that. So it'd be increasing from 0 to 6. And they want this as an interval. So 0 to 3, not 6. Over what interval is the graph f of x minus 4 increasing? So that means if we move it to the right 4 instead of to the left 3, or left 6 like this one, if we move this to the right 4 and this to the right 4, now we're going to be increasing from 10 to 13. Let me clear this out, it's getting too cluttered. Okay, what can be said about the graph of y equals negative f of x? So again, we had this function from 6 to 9, function was increasing. If we look at negative f of x, that's a reflection over the x-axis. Now it's going to look like this. And so now it'll be decreasing on the interval from 6 to 9. So decreasing on the interval from 6 to 9. Okay, now they want to know the same thing about not f of x, but f of negative x. That's a reflection over the y-axis. And that would mean it looks like this. This would be -6. This would be -9. So it'd be decreasing from -9 to -6, decreasing. Okay, starting with the graph of a basic function, graph the following function using the techniques of shifting, compressing, stretching, reflecting. Okay, so let's take a look here. So we know that this is a parabola, okay? I always start on the inside. This means we are going to move it to the left 2. So we're going to take our basic parabola, we're going to move it to the left 2. Okay, the 4 means we're going to do a vertical stretch by 4, a factor of 4. Okay, stretch it out. And then the minus, so that takes care of the 4. And then the -1 is going to move the whole thing down 1. Okay, so I need to somehow do this. So I'm going to take a parabola. Whoa, okay, so here we go. We want to, oh, they make this easy. We want a vertical shift. We want to, so vertical, we're going to add 2. Let's see what this does. Horizontal up and down, we're going to go down 1. And we're going to stretch by 4. Let's see what this does. By 4. Okay, let's see if this did it. We went to the, looks like we only went to left 1. Let me go left 2, hold on. Here, let me try it again. Okay. There we go. Now I can actually see it. Oh, that was our vertical shift. So we want it down 1. Want it to the left 2, so there. And then we want it to be scaled here by, want that to be a 4. I'll click into that box. Left 2, down 1. Let's save that. Let's try that. It's been moved to left 2, down 1, and stretched out. It's tricky. But what's the domain? Domain is everything because it's a parabola. So negative backslash infinity, comma, infinity. Oh, this is a mess. Negative infinity to infinity. The range goes from -1 up to infinity. So bracket -1 because it does take on the value of -1. -1 to infinity. Okay, how am I doing here? I'm only on number 14 here. Jeez. Okay, graph the following function using techniques of shifting, whatever. Find the domain and range. So this is a square root function that's been reflected over the y-axis. So it's a square root function. It's been reflected over the y-axis. And then the whole thing's been moved up too. So it looks like this right there, this one right there. So out of these options, I think we're here. Okay, and then domain. Where's it asking for domain? Continue. Okay, domain, so the graph actually stops here at 0 and it goes this way forever. So negative infinity to 0, including zeros. So negative infinity, comma 0, including 0. Okay, the range will be everything above. How much did we move it up? 2. So it'll be from 2 on up. So this range will go from the y value of 2, including 2, all the way up to infinity. Another one of these. Okay, so for this, it's the cubic function. So x cubed looks like this. Here's the x and y axis. So it looks kind of like this. Okay, that's what x cubed looks like. We're going to be, let's see, +4, we're going to move to left 4, 1, 2, 3, 4, okay. We're going to reflect it over the x-axis. So instead of doing this, it's actually going to do that. And then the whole thing moves up 3, 1, 1, 2, 3. So it should look something like that when we're done. But they make this a lot easier with this. So we're going to do the cubic function. Start it here at middle. Okay, we are not stretching it. We're doing a reflection about the x-axis. We are going to move it to the left 4. And then we're going to move the whole thing up 3. That should do it. Check it. Okay, domain is everything, negative infinity to infinity. The range is also negative infinity to infinity. Oh, I wasn't typing in there, darn it. All right, the graph of the function f is illustrated to the right. Use a graph of f as a first step toward graphing each of the following. Okay, so what is this function +3? That just means move it up 3. So that would be, it looks like this one. Okay. Okay, what is this one? So we're adding 2 inside the function, means to the left 2. So just move that whole thing to the left 2. That looks like, well, it's hard to see. Where does it hit here? Could be that one. Oh, but this one's been moved up. Notice it's been moved up also. Points went up and to the left, or no, probably just up. So it looks like this one. Everything's moved to the left too. This one looks like it moved down, and this one looks like it moved to the right. So negative f of x, that flips it over the x-axis. So that means this top goes down, this down goes up. It's got to be this one. Okay, this means we're going to move it to the left 2 and down 3. So left 2, but not, this is left 2 left, but it's not down. This looks left and down. This looks left and up. So it looks like this one. Okay, half of x, it makes everything half as big. So instead of going up to 6, it's going to go up to 3. So it should look exactly the same, just not as high. Looks like it starts at 4 pi and ends at -4 pi. So it's this one right here. Just doesn't go up quite as far. So it should be that. And what about this one? Negative f of x, that reflects it over the y-axis, which means this side should come to the left. This side should go to the right, should be D. Okay, 2f of 2x, that's going to actually make it compress it, it's going to happen more frequently. So this is like a horizontal compression. So instead of going and doing this between 0 and 4 pi, it should do it between 0 and 2 pi. Here, this right here. Okay, 3 to go here. Okay, so here we're going to complete this square and then graph it. So the technique to complete the square here is that we will take, make sure there's a 1 in front of the x squared, which there is. We'll take the number in front of the x, -6, divided by 2, which gives us -3. We will take that -3 and we will square it, which gives us 9. And now the important step, we take x squared minus 6x plus 8, and we rewrite it as x squared minus 6x. And then here's the important part. Here, we're going to add that 9 that we just got and subtract that 9 at the same time. And then we'll add the 8. So we're really adding nothing to this problem. The first 3 terms, though, will factor guaranteed to be x and then this number, -3 squared. And then you put these 2 numbers together and you get -1. So this will become x minus 3. And then over here plus, it'll be -1, -1. Okay, and then now we want to graph it. So all this is moved, since it's -3, it's to the right 3, it's a parabola, to the right 3 and down 1. So it's a parabola. We go down 1 to the right 3. There it is. Ah, another one. Okay. So same thing. We want to follow this procedure. Now notice there's a 3 here. So we have to get rid of that. So we need to factor out a 3 first. We'll have x squared. We'll have minus 10x. And then 79. Let's see, 6. Does that go in there? 3 goes in there. No. So what we do here is we put plus 79 over 3. And just if we check, if we multiply 3 through here, the 3's cancel, we get 79. So that's a valid technique there. Now I look at the number in front of x, which is -10. I divide it by 2, which gives me -5. I take that number and square it, and that gives me 25. So very important, I'm going to write 3. Then I'm going to have x squared minus 10x. Here comes that hidden 0. I'm going to add that 25, subtract that 25, and I still have 79 over 3. Oops. Do it in a different color. Still have that 79 over 3 here. Okay, these first 3 are guaranteed to factor to be x, and then that number here, -5 squared, and then I have to put these together. What do they want me to do there? Am I missing something here? 79 divided by 3. 3 goes in there twice. That gives me 6. And then 1, 9. 3 doesn't go into 19. So yeah, it's a fraction. Okay. All right. So we have that. We have to add those together. So we have to take -25 and add 79 over 3. So if I do that, put a common denominator here, multiply top and bottom by 3, we get -75 over 3 plus 79 over 3. And that gives you -4/3. This is going to be -4 over 3. Ah, I see what's going to happen. Okay, now distribute the 3 in front of that. 3 is x minus 5 squared. And then the 3 to here, the 3's cancel, you get -4. That's what we're going to graph. So this is a parabola. It's been moved to the right 5, stretched out vertically by 3, and down 4. Maybe I should put this here. 3 minus 5 plus -4. Uh-oh. What? What's going on here? Oh, shoot, I see what I did. This was a, oops, this was a positive 4/3 here. Sorry, positive 4/3, positive, positive. That should be a plus. My fault. Getting a little bit too lazy here. Okay, there we go. All right, let me clear all this. We want to do those shifts. So we want a parabola, starts here at the beginning. We're going to go to the right 5. Oh, that's vertical. Right 5. There's right 5. We want to make it go down, up 4. We wanted a vertical stretch of 3. Save that and check it. One more. Okay, last problem. Why is it counting these partially correct? I don't get it. Okay, so the same thing here. We want to first factor out a -2. That gives us x squared plus 10x minus, I pull a 2 out of 49, it's going to be 49/2. Okay, we take the number in front of x, which is 10. We divide it by 2, which is 5. We take that number and square it. We get 25. So I have -2 x squared plus 10x. Here we come in here with this magic number, plus 25 minus 25, and then minus 49/2. Okay, this is -2. Then these 3 are guaranteed to be x, and then this number, so plus 5 squared, and then I still have to do these 2 together. So I'm taking -25/1, and I'm subtracting 49/2. This is a common denominator, -50/2 minus 49/2. And am I getting that sign right? Yeah. Okay. Oh, wait, hold on. I pulled a negative out. Shit. Sorry, this should be positive. My goodness, Robert. -1/2 here. Now distribute here to here, -2, x plus 5 squared. Here to here, you get 2 negatives become positive, and it should just be +1. All right, so -2 up front. That should be +5. And then the last one +1. All right, now this means we're going to take a parabola, starting out at the origin. We're going to move the +5 means to the left 5, not 6, 5. A vertical stretch by -2. So it's a stretch by 2. Stretch by 2, but it's negative, so we want to reflect it over the x-axis. And then we'll move the whole thing up 1, vertical shift up 1. There we go. All right, we are done. That's it.